Okay, in this problem, we're given all of the data that you see above this line that I just drew in, and we are asked to, for our first problem, find the rate law. Okay, so let's take a look. In experiment 2, which is this column of data right here, we can note that our H2 plus concentration is halved every 10 seconds. So only first reactions, first order, have a half-life that's independent of concentration. Knowing that, let's do our rate law right here. Rate equals K times H2. That'll be first order, so we're not going to put a value in. And then look at experiment 1. We can see our half-life is at 40 seconds. And if you look right here, our half-life is 40 seconds. We can see between this and this, half is gone. So that means that from okay, I was going to write this up here. Okay, from experiment 2 is the NO concentration is doubled from experiment 1. And we can see that, and from that, the rate increased by a factor of 4, which means that when we're looking at this, this has to be second order in the NO. So it'll be NO second order. So there's my answer for A. Okay, and then what problem am I on here? 1286. Oh, sorry about this. Got a big yawn there. Okay, for part B, solve for the rate constant. Include units. Okay, of course, I'll include units. Okay, so this is going to be pseudo first order in H2 as the concentration of NO is so large, it's basically constant. So looking back at our data, this is so huge. So it's hardly going to change at all. So this is, since NO concentration is so very large, this will be pseudo EUDO first order in H2. So that would be like K prime H2, where is equal to K NO squared. So the first order reaction our integrated rate law will be ln of H2 over H2 original equals negative KT. And we can use any set of data. Let's use experiment 1, 0 to 20 seconds. So we're going to take the ln of 0.0071 divided by 0.010. This will equal K prime 20 seconds, and our K prime will equal 1.7 times 10 to the minus second, s to the minus 1. Okay, then my K prime will equal K times NO3 to, it was NO, to, and that'll be 1.7 times 10 to the minus 2, s to the minus 1, equals K times 10.0 moles per liter squared, and I get a K of 1.7 times 10 to the minus 4, L to the 2, mole to the minus 2, S to the minus 1. Okay, so there will be my K with units. And then last but not least, let's do C. C, calculate the concentration of H2 at T equals 30 seconds. So if you go back to the table, you can see that this value was left blank, so that's what we're solving for. Okay, so we know that the ln of my H2 concentration will equal negative K prime T, which will equal negative 1.7 times 10 to the minus 2, L to the 2, moles to the minus 2, S to the minus 1, times 30 seconds, and that'll give me my H2 concentration equal to 6.0 times 10 to the minus third molar. Whew, we did it.